Duncan, and this is a quick tutorial for how to do automatic pin swaps in JITX to optimize the routability of your design. So here I've got a simple design loaded in, an ST microcontroller in this TSOP package here, a transceiver with a UART interface, and I've got a require statement. So this says require something called USART, which is a USART interface with RX, TX, and CTS from this microcontroller. And then I connect it up to the transceiver. So here you can notice that I've got these nets between the two devices here, and they're able to move around. Not in too many places. You know, the ST microcontroller supports UART in a few places, but I get to interact with that on the fly. So instead of cross-referencing the datasheet and finding out which pins support UART and which configurations and then editing the schematic, I can instead just say, you know what, just route my USART interface here between these pins. So as another example, I can say I'm going to add a Nordic chip and connect an SPI interface. So let me uncomment that. Okay, so now I've got a Nordic chip here, and notice that there's a lot more options for pin assignment here. There's a package really optimized for routability and a low layer count. So they've added a full I/O crossbar. So I need to escape this little pin down here, pull vias, and then assign these pins. And now I've created my SPI interface between these two devices. Again, I didn't have to go look up the ST micro datasheet. I just can make the connections directly in my router. And it's not just for things like SPI or I2C or DDR. You can actually use this for any interface. So here I'm going to make a connection of 4 ESD protected GPIO. So I make a little dummy bundle in here, and then I can add this ESD chip, which has 4 channels per device. And I can make a little map, say like, you know, I just need 4 protected IO. And make the assignment. Okay, so now I've got my IO here. Let's bring those in. There's a connector. There's the ESD. And notice again I've got the flexibility. So let me line this up. And so I like this little ESD chip. It has a nice pass-through for all the components. So there I've got my signals. I don't really like that one, and I have the freedom to reassign it to whatever pin I want, really. And now I can say, okay, let me route those. And that's kind of an exotic way to write low inductance signals, so instead exert more specific control. But notice that it's pin assignable, right? So I can map any pin to any capable pin. So there's automation here, there's checking here, but I can also lock in the choices that I want. So that was a quick demonstration of pin assignable routing. So optimizing the pin assignment as you go along without having to leave the routing interface. Thank you.